Just gonna have to test my audio again. Just gonna. Cool. Yeah, just starting from where I left off, but also having a beer as well. hmm Guinness is great. On holiday, I really missed like English beers. I don't really know why. Uh, and then I thought, you know what? Actually, I'll have a Guinness instead, a bit of an Irish beer. And I was like so gobsmacked by how good it was. This is in the other country I went to. And when I came back, I was like, I have to go and get some Guinness because that is so good. So hats off to Guinness makers. I'm not sure if it's vegan. It probably isn't, but it's good anyway. Yeah, okay. So I've got a few confusions about how this differentiation kind of come, like where all the parts come from. So I'm just going to work through this very slowly and try and figure out where the bits come from. And then of course we have to differentiate it. So there's going to be a lot of me Googling differentiation laws, which I forget. Um, yeah, okay, so starting with this, we're talking about negative gradient of a loss function. It says, using gradient descent, we can now update the model parameters by taking a step in the opposite direction of the gradient. So we can update the model's parameters by taking a step in the opposite direction of the gradient. So this one, our W, our loss function with respect to weights, we're updating as we go down. Updating by this change. And it says the change in L, the change of the loss function, LWB. And it's highlighted W, but I think, it's funny because in the beginning it says about naming conventions, and I think an emboldened or a bold letter is a matrix or a vector, I can't remember. So anyway, I think we can assume though this is a vector of W's, right? It doesn't. Oh, I need my fan on because it's bloody hot. It doesn't mention the indices here as well, so it's kind of a very common or general statement here. Whatever the W was passed in, um, well, whatever W I'm working out, this is how you do it, and whatever B, this is how you do it. The parameter changes W and B are defined as the negative gradient multiplied by the learning rate. So W is the negative gradient and B is the negative gradient. Thus, change in W is equal to the negative of the learning rate multiplied by the negative gradient with respect to W of the loss function. And that means to compute the gradient of the loss function, we need to compute the partial derivative of the loss function with respect to each weight Wj. So we're doing this with respect to Wj. And then they're doing it with respect to respect to B. So if I just modify this a bit, so this makes sense to me so far. Oh, no, okay. Can I get a bigger? That might be quite helpful actually. Let's go for the entire stroke. Yeah, that's good. We like that. Okay, so let's just change this a bit. So this is the derivative of L with respect to partial derivative of W, J, where J, I think, is in reference to the example, but that the whole set of features with their weights are contained within that. So this will equal, now we have to differentiate this for W. Now this is where I don't understand it, because the change in W is equal to that. So the function W, so they've got, I just, similarly, we compute the partial derivative of the loss function with, so I understand that. So then it's gone, it says over here, actually it's got a bit of a helper. So please note that the 2 in the numerator above is merely a constant scaling factor. We could omit it. Fine. So we can write the weight update as the update of, yeah, exactly what it said basically. So the learning rate multiplied the negative of the gradient, and the same with respect to B. Since we update all parameters simultaneously, our Adeline learning rule becomes this. So then it says, if you are familiar with calculus, questionable, the partial derivative of the mean squared error loss function with respect to the jth weight can be obtained as follows. So they're starting with this. So let's go and look at this. They're saying the partial derivative with respect to wj 1 over n times the sum of y, example, sigma z, sorry, I squared. Now, it's saying that that is equal to flipping this around. So is also equal to 1 over n, and then this. Which is right? You're going to multiply, they're commutative, so all is well. Commutative, is that right? Yeah, I think so. And so they're saying that the next step then, so it's therefore equal to, now they've got 2 of these things, so I'm guessing that they've squared this out, right? So this makes a little sense, but then this 2 over n, it's a bit difficult because I think this is using the chain rule. So let's just double check. Let's just double check the chain rule. So differentiation chain rule. Yeah, so here we go. I'm saying so a lot. The chain rule states that derivative of g of x is, no, the derivative of the function g of x is the derivative of g of x multiplied by the derivative the derivative of function g of x is g of x multiplied by the derivative of g of x. In other words, it helps us differentiate composite functions. For example, sin squared is a composite function because it can be constructed as g of x for f of x equals sine of x, yep, and g of x equals x squared, yes. So in this case, this could be a term or a function, and I suppose just correct that for a second. I suppose that whole thing can be a function, but it doesn't really shout out to me that that is the correct way of thinking about this. Yeah, let's watch this.
Core principles in calculus, and you're going to use it anytime you take the derivative of anything even reasonably complex, and it's called the chain rule. And when you're first exposed to it, it can seem a little daunting and a little bit convoluted, but as you see more and more examples, it'll start to make sense, and hopefully it'll even start to seem a little bit simple and intuitive over time. So let's say that I had a function. Let's say I have a function h of x, and it is equal to, just for example, let's say it's equal to sine of x. Let's say it's equal to sine of x squared. Now I could have written it like this, sine squared of x, but it'll be a little bit clearer using that type of notation. So let me make it. So I have h of x. And what I'm curious about is what is h prime of x? So I want to know h prime of x, which another way of writing it is the derivative of h with respect to x. These are just different notations. And to do this, I'm going to use the chain rule. I am going to use the chain rule.
Now, that's interesting because I can't remember his name now. Is it Jason or I can't remember the guy's name, but he will have to do for now. He's saying that there are two functions here. So if we do it with respect to x, so let's see, this one we could do with respect to x squared, or whatever this is squared. So maybe this doesn't quite apply here yet, at least. So we have this subtraction or difference rule, or difference law, and then we also have this function thing, which I suppose in a way that is that, because we're multiplying. So this is the function 1, and this is the other well, it's not, is it? Because we're just passing in a value here, so it doesn't really matter what that is. And if we go back to what's happening in this here, it's saying that there's a 2 from, so let's start with this multiplication. So it's the sum of all of I, and we're squaring this out. So that means, so I guess when you square out this, yeah, because this is it, isn't it? Because this is why it's talking about the gradient here. It's actually saying, yes, okay, so this is in one of the rules. So this is saying take the original and then multiply that by the gradient of the original. So if we go look at this again, it says oh, it's a PDF. Yeah, Yeah, okay. So h derivative of x is equal to the function derivative. Oh, okay, so what's h of x? In calculus, the chain rule is a formula that expresses the derivative of the composition of two differentiable functions. Yep, f and g, in the terms of the derivative of f and g. More precisely, if h equals f, I can't remember the open circle is, mathematics, circle with empty center. This composition, and is defined by, so this is a composition, okay. Oh, that's interesting. So yeah, I think there's a composition function actually. So laws of differentiation. Here we go. So we know this one. Oh, I know this one. Constant is equal. I know that one. Derivative of constant multiplied by a function. Constant multiplied by a function. So that's this O thing. Constant multiplied by a function. So we might be able to do derivative of the function. This one. I think I got the best. No, this is not great. Let's just go and get an image of this. Yeah, this is better. Um, Derivative formulas. Yeah, this looks good. Haha, okay. I've got an itchy nose, gosh. Constant multiple rule. Now they've got f of x plus g of x is the same as saying the derivative of x plus the derivative of g of x. And we've got the difference rule. Here it is, look. F of x, so that's not that, is it? That's essentially not that. And we've also got the power rule, but so I don't think it kind of works out at that point. So what about this quotient rule that we're not dividing? The product rule, one multiplied by the other. So f of x, g of x is f of x times the gradient of g of x. And the chain rule, so it might be this. The gradient of g of x multiplied by the derivative of the function g of x multiplied by the derivative of g of x. Function g of x. So if we go, actually I'm going to just take a snippet of that because I think that is basically what we need. Oof, get a bit complex here. That's basically what we need. If I go back to here, minimize that now. It's saying we take this, and then we multiply it by the gradient. We take this, so this is the gradient of the loss function with respect to wj. So this becomes 2, I guess, because 1 over n times 2 is, let's see, yes, okay. But that's not for this outside part. That would be down here, so it'd be 2y. No, it wouldn't be because this is a function. So they're trying to express the fact that this is a function. But you're going to get, let's just start with this. So you're going to have to get yi minus sigma zi, and you're going to have 2 of these, right? Because we're squaring it. Now, this derivative part is already in here, but there's also this 2 has appeared. So this 2 over n, because if I use the product rule here, or the exponent rule, whatever it's called, this will be this times 2. 2 times of this. Aha! But then it will be 1, 2 times this. Well, we could have that. No, but it's not 2. Yeah, it is that, yeah. So it's 2 times that. So more so it would be like that. And then that would be 1, which would make it just that, 2 of that. But instead, this is the sum of everything. So I wonder if this becomes an entire, because this is an entire term. But this is a function within itself. So why is 2 of n? Where does it come from? Let's see if it says anything. The same approach can be used to find the partial derivative of a b, except that b is equal to minus 1, and thus the last step simplifies to how does that 2 come about? I don't get that yet. Because the squared term, so the exponent, is within the sum, and that's important because it's going to be everything plus each other. Then again, if you yeah, I don't know where that is coming from. So let's have a look at this then. So g of x, f of x, so this is divided by product rule is f of x multiplied by g of x. Okay, let me see if this is going to help again. We'll just go back to this. Not that. It's the function. It's the composition of two differential functions. Yeah, I did learn that. Damn it.
The chain rule comes into play anytime your function can be viewed as a composition of more than one function. And as that might not seem obvious right now, but it will hopefully maybe by the end of this video or the next one. Now what I want to do is a little bit of a thought experiment. If I were to ask you what is the derivative with respect to x, if I were to apply the derivative operator to x squared with respect to x, what do I get? Well, this gives me 2x. We've seen that many, 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 many times. Now, what if I were to take the derivative with respect to a of a squared? Well, it's the exact same thing. I just
Um, yeah, so if it's a squared, it's going to be 2a, then it'd be 1, so it's just going to be 2a.
swapped an a for the x's. This is still going to be equal to 2a. Now I will do something that might be a little bit more bizarre. What if I were to take the derivative with respect to sine of x, of sine of x squared? Well,
Well, you're going to get 2, you're going to get two functions, so two functions multiplied together. So this is the derivative of sine of x, so it's just going to be x squared, so it'll be sine of, I don't know,
wherever I had the x's up here, the a's over here, I just replace it with a sine of x. So this is just going to be 2 times the thing that
so 2 times sine of x, that's it.
I had. So whatever I'm taking the derivative with respect to. Here was with respect to x, here with respect to a, here's with respect to sine of x. So it's going to be 2 times sine of x. Now, so the chain rule tells us that this derivative is going to be the derivative of our whole function with respect, or the derivative of this outer function, x squared, the derivative of x squared, the derivative of this outer function with respect to sine of x. So that's going to be 2 sine of x, 2 sine of x. So we could view it as the derivative of the outer function with respect to the inner, 2 sine of x. We could just treat sine of x like it's kind of an x, and it would have been just 2x, but instead it's a sine of x. So we say 2 sine of x times the derivative, let me do this in green, times the derivative of sine of x with respect
Which
to
is
x, times
cosine
the
of x.
derivative of sine of x with respect to x. Well, that's more straightforward, a little bit more intuitive. The derivative of sine of x with respect to x, we've seen multiple times, is cosine of x. So times cosine of x. And so there we've applied the chain rule. It was the derivative of the outer function.
So the derivative of the outer function is going to be 2 this, and then the inner function, the derivative of that, times uh, uh, y is a constant, and then you've got this function. um, y is a constant, because one goes here and there'll be 0, so it'll be 1. So 1 goes here, it'll be 1 times y, but this is all to the power of 0, so it's y goes away and you're just left with 1, so it's going to be 1 minus sig. But then we've got this difference rule, so we'll do the difference rule next. That's going to be, but these are functions. But then again, I mean, I was just about to do that, so that's interesting, isn't it? It's actually saying, so this would be, um, where's the other one? Yeah, this one, chain rule, even for this one. So we do the derivative of the multiplication, and that is probably going to be here. Constant multiple rule is going to be the derivative with respect to x. So then it's going to be z, it will be 1, so it'll be sigma 1, 1, 1 times sigma. This gets to 0. It could be 0. This whole this whole thing could be 1 sigma, which should just be sigma. Um, and 1 take away that is 1 take away that. They're like terms. You can't. They're not like terms. So they can't do that. Uh, and then it's going to be 2 y I minus sigma z I plus um, y I sigma minus. Oh, what's the term here? It is plus, yeah, it's plus. So it's plus y minus that plus y sigma minus sigma squared. Well, this is it's yeah, it's going to be. I wonder if it does this. So you just like square this because there's two of them, right? I don't know if that's right. Now it's 2yi, so it's going to be um, equals 2yi minus 2 sigma zi plus, or 2 minus 2 minuses is plus. It's going to be that 2 times minus 2 minuses minus 3 times minus 3 is, yeah, and then plus 2 y I sigma. I don't think this is right. And then 2 negatives is a positive, so 2 sigma zi but 2, it's two of these. Okay, that's fine. Uh, and then is there any terms I can cancel out? Let's see. 2yi, 2yi, o. So it's 2 times 2 is 4, y, I. I don't know if you can actually do that. Let me see. 2, 2 sigma 2i. So this is interesting. So it's the same thing, but that's squared. 2yi is multiplied by that, so that is a value on its own. And if I were to multiply it by 2yi, so if I go back to the the kind of answer, let's say, I don't think that's really right at all. So let's imagine we have this sum of thing, and so the sum, what's the derivative of a sum of? Derivative of a sum of. Sum rule for derivatives states that the derivative of a sum is equal to the sum of derivatives. The derivative of a sum is equal to the sum of the derivatives. So it's that plus that. So that's why if you divided it by 2, yeah, so it's going to be that plus that, if I've done this right, obviously. I don't think I have. So then this is now, how are we looking? So if I were to, so if you go now 2 divided by n, because if I divide, yeah, no, that's not right. So, interesting. So they've kept the sum in there. So they're not differentiating that at all. They've kept it in there. So that is not what they're expecting here. That cannot be right. And this I don't think this is right as well. Though it does feel right because it is basically that. It's 2 times that, 2 times that, and because it's a 1 here, it remains here, right? Ah, but of course you have to do it for each term, right? So it's gonna be, let's just see here. If you do x squared like that, that's fine. But if you do x plus 1 squared, it's gonna be x plus 1, x plus 1, right? So I need to think about this here. Actually, this is wrong in that case. Wrong, wrong, wrong. um, so it, this is as well, I think. So let's try this again. Maybe we move this out of the way so we just remind ourselves that yeah, putting the blame on you guys. That's wrong. That's good to know. So now if I try again, we're going to do yi minus sigma zi times yi minus sigma zi. This will be yi2 yi. Oh, I think I already did this actually, didn't I? 2yi plus 2. Okay, this is different. So this is positive, That's positive, great. So now let's work on to this one. So do that one, and then plus and a minus is a minus. It's going to be y I sigma z I, and then we're going to do this one. It's going to be minus and a plus is a minus, minus 1 plus 3 is a plus, sorry. So what was this one? This is a minus and a minus, that's a plus. But minus plus, this is a plus. So it's going to be plus y I sigma z of I, and then it's minus and minus is a plus, is o, sorry, sigma uh, z I squared. Yeah. Where are the like terms? Let's see. There's a 2yi minus that, but these are multiplied together, so you can't do that. Plus, right, so these are like terms. So there's a minus yi plus a yi. So minus 1 plus 1 is 0. So it's 2yi plus this z, whoops, z I squared. Let's just, so two. So this is minus and a plus. That does cancel out. So we're left with 2yi plus oz. That's fantastic. Okay. So now, so now I've done that squaring of everything. Now they don't have that 2. So I do have a 2, but I've also got a squared. Which is interesting. So if I were to say, if we were to say that there's well, they keep it there, so how do they move that over there? If I were to say, I know the sum of 2 plus 3, where I equals 1 to 3, that's 5, 10, 15, right? If I did 2 times that, if I did this, but 2 times that, or 2 times 15 is 30. So that doesn't help. So let's say, let's just start with x. So it's x, and then you've got 2x. X plus x plus x. X plus x plus x is 3x. And this is going to be 2 times x is going to be 2x, 2, 4, 6, 6x. Now if I was to divide that by 2, I get 3x. Aha! So what the hell is this n then? Is this just bad notation? Like, cause I mean, what's the I here? The n is the iterations maybe, and the I is the example. So the n is the iteration. So it's 2 divided by the number of iterations. So if I was to do this, 2 divided by the number of iterations, 2 divided by the number of... Oh, I'm off the camera, I didn't realise that, sorry. Let's try that. I hate these camera things. Okay, is that better? Let's see. A little bit too high now. Maybe it was okay. Maybe I just, because I was focusing in too much. Um, that's interesting because that is the same outcome, right? So one might assume that indeed if I were to take this out of the sum and divide it by, but this is the problem because now we've got, so the 2 is actually connected to the 2y. It's not connected to that. I've already processed that one out. Now, squared is interesting because maybe they just divided that by 2, but then why do you have the differential multiplied here? So it's this, and if we go back up to our rules, we've got the outer multiplied by the inner. So the outer multiplied by the inner. Chain rule. Outer multiplied by inner is equal to the derivative of the outer. So the original was right. No. Yeah, exactly. Yeah. So this was right. So if we're going for the chain rule first, then this would be 2, which is good because then we have that 2. Y I minus sigma z of I that would be moved to 1, which makes it just a 1. And then it is saying derivative of that, and then multiplied by the derivative of the inner of the function. So what's the derivative of the inner of the function? That is the subtraction rule, or the difference rule. Well, no, because this is constant, so it's just I guess you can just write that. Yeah. Okay. I see. So this is fine because if we divide it by 2, now this is a problem though, because this is going to be um I totally understand this now though. That's great. So Wj is gonna be sorry, the differential of sorry, the derivative of yi minus sigma zi. That makes sense to me now, but we've still got a 2, and this is going to be the sum of I 1 over n, right? And that's the loss function with respect to Wj is equal to that. Well, yeah, okay, well, yeah, that's correct. So now if that's the case, if I were to have two terms in my little test down here, if I had this instead, the sum of I equals 1 to 3, where you've got x plus, well, x, y, this would be 3xy, and this would be, this is, wait, what did I do here? X and then 2x, yeah. And so if I did this 3I equals 1, see if there's anyone watching this. Sorry if there is. Nope, that's cool. This would be 2x times y, but it's 2xy, so it's interesting because it's commutative, right? It doesn't matter. It's going to equal, so 2xy is going to equal 246xy. And then if I divide that by 2, I get my 3xy back. I think that's proof. Well, not proof. You know what I mean, though. Like I feel like I'm making good assumptions here. And so that is actually fine to move to 2 over n, the sum of I, and then that 2's now gone. So now it's going to be y I minus sigma of z I multiplied by the derivative with respect to wj of that sigma zi. Whew, I think I got it. Right, well, we're there with them. Yes! Come on, dudes. This is awesome. Celebratory swig of beer. We are with them. So that was, what rule was that again? That was the chain rule we used. Chain rule. Tick. Okay, cool. I like it. So now we've got to continue this down. So then they're saying they're trying to, I mean, now they're substituting in the sigma, which is the dot product plus b, and so that becomes Yeah, okay. So that's a constant, so that goes. And then this is going to be square 1. Um, so they've got it as equaling. So what's the derivative? I see. Oh, what's the derivative of this? I see. So now we differentiate this. Okay, okay, okay. So that's, yeah, that's step 1. Ah, man, this is easy. Ugh, the tools aren't great though. Ooh. Right, so we like this. Let's get that. Let's move that down somewhere nice. Oh no. Why is it such a bad, like, oh, can I can't move, like, at all. Can I do that? Nope. So I can't move. Let's try this one more time. There must be a way of doing this. If I do that, so I'm going to move this down here, and then I'm going to, yeah, no, you can't do it. Oh well, that's fine. So we'll go here, and so now the derivative of w is going to be um, y I, what was it again, minus yi minus the sum of wj xj on the ith plus b. Okay, yeah, we understand that. So that's, we're going to differentiate that with respect to wj. Um, yeah. So this is interesting. So this is just plussing a constant. So the constant definitely goes. So it becomes that wjxji, and then because this turns out to be, and this is a constant as well. So that goes. I see, I see, I see. So that goes and that goes. So now we're left with the sum of, and this is left with negative. I see, because this is negative sum of. I see, I see, I see. Whew, this is difficult. That last part, yeah, it's hard to track these things though. So that's going to be the negative of whatever's the sum of in there. And then how do they get rid of the w? The w is removed because if I did 1 to this whole thing, you'd get 1 wj xj. 1 w. Oh, that's interesting. No, I didn't understand this yet. So maybe there's another rule for this. Let's go look at our rules. Let's see. It's going to be a constant, no, that's a function of x. A constant multiple rule. Constants times a function is equal to the constant derivative of x. It's not that. And n of x minus 1 is only for that. So we've got this product rule. Yes. So that is the function of x. That's going to be wj multiplied by the derivative of x. plus x multiplied by the derivative of w. So let's do that. Let's just take a copy of that actually. That is the product rule. Okay. So if we do the product rule, um, it's going to be wj times, uh, well that's going to be 1, so it's 1xj, 0 is going to be 1, so it's 1wj, well times 1, so that's, and then it's plus xj multiplied by the derivative of wj, which is 1. So then it's wj plus xj. Uh, so that is not what they've got there. Was there one for plussing actually? Because that would be interesting. Sum rule plus, that's a function plus g would be the derivative of that plus the derivative of b. B is 0, so that's fine. And the derivative of that, I mean, we've just essentially done anyway. The derivative of that is going to be, how'd they get rid of that? Oops. I don't know. Whoa. Oh, this is interesting. Ah, how have they gotten that down to negative xj? I understand the negative because the sum of everything is going to be like negative plus a negative plus a negative. No, that's a positive. I guess, yeah, because so there must be some, so negative xj square of that would be times 1 plus, oh no, why did I do plus? It's, that's wrong. This is wrong. Try it again. It's going to be wj xj. Let's say x y squared. So let's say x is 2 and y is 3. So that's 6 squared is 36. But then if I did 2 squared times 3 squared, then that's going to be 4 nines 36. They're the same. Okay, that's good to know. So if that's the case, it doesn't really matter I'm going to be squaring them both. And if I square them both, that means I get 1j 1x. No, I don't. No, I don't. That's, I get, oh, there's a comment here. What's happened? Oh, I think it's just saying I'm recording. Sorry, I was just looking at my streaming thing. Wow, I completely lost. I completely forgot I was being streamed then. Um, yeah, so this will be 1wj times 1xj, right? Which is 1 times 1 equals 1. But then I've lost my x. I've lost my x. Hmm. But they are equal if I do that. How to differentiate a times b. Gradient power rule. Derivative of constant function c equals 0 for any constant c. Derivative of identity function x equals 1, proof of 2. The sum rule. The product rule. UV, this is the one. It's u times the product rule. Okay. So where is that on this? So I did do the product rule. Because I think I copied. Yeah, I did. So where did I go wrong there? I did f of x is going to be wj. Oh yeah, so I did do that, didn't I? I did already do this. It's going to be wj multiplied by 1. It's funny because there is a term there. It's the ith of xj. And then it's plus, and it's g, which is xj, xj, multiplied by, and f of x is 1. And that's what that's saying. U times the derivative of v plus v times the derivative of u. Oh, so how the hell did they get that? What am I missing? How does that become a negative xj? There's something... These are BODMAS, so you've definitely got wj plus xj. And then the sum of rule. Oh! Hang on. The sum of rule was the differentiation of the sum of is equal to the sum of the derivatives. So the derivative of wj is nothing, is 1, plus 1. Oh, how does it go from that to that? I cannot see that for the life of me. What am I missing here? What am I missing? Multiply by the... and then multiplying... Whoa, what? Ay, ay, ay. Oh, I wish someone was watching to help me. That would be top dollar right now. That would be top dollar. But nope. The term remains, so it's still the negative of the sum, and the sum must be derived. So maybe I it's to it's different. I need to differentiate what's inside, and to do that, it's this whole term. So it's b goes and wj xj. I mean, it has to be 1 times 1, which is 1. So then it's... So why is it xj? Is that even right? The same approach can be used to find partial differentiation. Plus is equal to -1, and thus the last step simplifies to... Is that really right? I wonder if I can Google this, get some help. I'm just missing a rule or something. Um, differentiate an equation online. Calculate the derivative of sum, help. I don't know how to do the sum of... is it that? Sum of... latex, come on. Yeah, I actually can't remember latex. Let me just refresh this. Sum of 1 plus 2. Ah, maybe that'll work. Latex of sum of sigma. Let's try that. Sigma. Oh, is it that? Like that? Maybe it's then sum like this. Gosh, no. It's sum underscore. Yeah, okay, I think that makes sense. But this is not liking this. So, right, function. Phew, okay. Wow, let's try a different calculator. Maybe the Wolfram one's better. Here we go. Have we got the sum of here? Sum of. Oh yeah, here we go. Ooh, nice. I like this. Wolfram Alpha. Good. This is differentiate W, and then this will be sum of uh, I. Well, yeah, equals 1 to 2. And this will be W x plus B equals 2x. Sorry, so how did it how did it do that step by step? Here we go. Rewrite the expression. This is I. Well, it's a bit annoying that because this is it's a bit like arbitrary, isn't it? I wonder if I can change that to just say I and then compute that. I equals I. Can I do that? No. I equals A to A. X. Okay, that's better. So let's see what they do. Rewrite the expression wx plus b is equal to b plus wx. Differentiate. Ah, differentiate x. It's differentiate b plus x times the differential of w times b. Wait, what? B plus x times the differential of w. Oh, is that? No, that's right. Yeah, of w. Darn. I don't really want to play anything at the moment. online differential equation solver. So that's differentiate the sum of wx plus biaa. That's wrong. Yes, we want the sum of plus b. Um, sigma. Nope. Where's the sum of? Maybe it doesn't really matter. If I just do wx plus b, I wonder what happens. It's going to say x1 equals wx plus b. Negative b w equals 0. So x1 is equal to negative b divided by w. So it says at the same time, so, so it's partial. Is it a partial differential we have to solve here? Because if we solve it for w, w1 is 1. If we solve it for xj, w times. Okay, so I think I understand this. So if the parameter, wait, at the same time it changes sign into the opposite. If parameter w equals 0, then wx equals negative b. Therefore 0 does not equal negative b. W equals 0 with restrictions. W doesn't divide both sides up of the equation by w. Oof. Um. Wow. Documentation on this is a bit flaky, isn't it? Like, God, can't I find this somehow? Damn it. What are we trying to do here? Like, how can it get to negative x? Let's because we're only doing with respect to w. Oh my God, yes, that's why we are only differentiating with respect to w. So the x is left because it's one, and then it's just 1x. And why is it negative? Because it's the sum of all, the negative sum of all. Oh my God, that makes sense now. So it's because, okay, right. It's because we are only differentiating with respect to w. So the constant goes, and then x is not touched at all. So if we differentiate only w, we get wj to the power of 1, that's 1, that becomes 0, that becomes 1 times, and then x, which is left alone, and then it's the negative sum of everything, so it's just going to be negative xj. we did that part. Good. And now the last part is... Right, we understand that now. So the last part is... the negative xj... Well, let's just write it out so I don't confuse myself anymore. Got 2 over n I y I minus sigma z god z negative x j of I is equal to, now it's it's got to divide that, isn't it? Let's see, if I do this, what actually happens? So if I multiply out these brackets, I'm going to get y I times negative xj times negative xj I minus, that's, let's just do that, uh, minus sigma z I times a negative, so sigma plus a negative equals a negative times negative xj I, right. So this is going to be there's two like terms, a negative and a negative is a positive, so we've got let's put this down here actually, like that. So we've got, these are like terms, they're negatives, but they are multiplied to this. Negative. So negative 1 times negative 1 is 1, so it's going to be wait, let me just check that because I think I'm being an idiot now. Sorry, sneezing. So negative 1 times negative 1 equals 1. That's right. Okay, good. So I guess that becomes xj. Let's just imagine that becomes xj for now because I'm not sure. And then that would be multiplied by the following thing, right? Y of I minus sigma of z zi like that, which I think is what we got here. Yeah, it is. Oh, that's interesting. And then we're still left with this negative 2 over n. Ah, now where did the negative come from? That's because... Oh, so where's the negative come from? Ooh. It's become negative. And it's come from here. Hmm. Where has the sign gone? So if we're multiplying out these brackets, we've done this, but why is a negative carried across? Because the sum of all this was, what was that again? The sum of all that was, oh yeah, with respect to w, so that's why we got that negative there, yep. And then, uh, oh, my brain's gone blank. My, that says a lot about my brain has gone blank. Um, if I want to take away, why is that? Why does that get done like that? Negative xj. If I do another test, let's say two, well, the sum of um x negative j, x negative y, then there's no differentiation happening here. Apparently, I can do, I can move that out of here. So let's see if there's a rule for that. Um, multiplying negative within a sum. Within a sum of sum of the product of a positive and negative. The product of two numbers is positive and their sum negative only when the product of two numbers is positive and their sum, correction, both are negative. The product of two numbers is positive and their sum negative only when both are negative. Um, uh, oh, this is the easy bit. Why am I struggling here now? If I multiply that, it's something to do with the, yeah, let's try this again. I think I've missed something here. So if I do, let's go back to this. Maybe I'll just copy it actually. So this would be yi multiplied by a negative, so a positive and a negative. So three minuses is a minus. So it's negative xj, but it's multiplied. It's negative yi xj, right? and then it's and then I'm going to do this one. Minus and a minus is a plus plus. This said I x j I. So now negative y xj plus sigma xj. Well, this would be moved down to here. So they are a positive and a negative. Negative 3 plus 2 is 1, so it's going to be a positive. I don't think there's any terms I can, because this would be xj squared, and it's not what's happening here. Ah, man. Let's see if we can get this again. Equation calculator. Well, actually, maybe this is just very simple. Let's just move this over again. I have to remind myself that I can do little tests, so let's just do another test. So if I had 2 times the sum of a um, a and negative b, so this would be 2 negatives is a negative, so it's going to be negative a b, right? And it's going to be 2 times the sum of, let's do this as yeah, that's fine. And so if a equals 2 and b equals 3, you've got negative 2 times 3 is negative 6. 2 times the sum of negative 6 is positive. Is positive. 2 times negative 6 is positive. And then if I just move to negative 2 times the sum of AB, then then 2 times the sum of 6 is 12. They're equal. That's all it is. They're just equal. Well, I didn't bloody know that. God. So they've just negated it because for some reason, I suppose. I guess it just removes confusion. because you always know it's going to be, well, see, they're trying to negate it. So whatever this is negated. Oh, hang on. No, that's okay. I don't understand why they've done that. Um, yeah, and the same goes for this, so that's fine. So although the Adeline learning rule looks identical to the perception rule, we should note that with z equals is a real plus b is a real number and not an integer class label. Furthermore, the weight update is calculated based on all examples in the training dataset instead of updating the parameters incrementally after each training example, which is why this approach is also referred to as batch gradient descent. To be more explicit and avoid confusion when talking about related concepts later in this chapter, we will refer to this process as full batch gradient descent. Well, I think I've calculated this right. Um, to be honest, I'm not entirely sure, but you see, it just goes on a bit, doesn't it? So we started off with the chain rule, went to the product rule, and then the rest was just your average. Well, and then we had to remember that you need to partially differentiate with respect to the one variable, and then it was just normal, like just figuring stuff out. Whew. Wow. Okay. Well, I'll stop there. That's good. Good. That's exactly what I wanted to do this session. So I think I understand the math. I think what I'll do is ask a friend, call a friend, though, because I'd like to know why they want this as a negative at the end. I suppose the answer might come out of the woodwork somewhere, but yeah. Cool. Well, thanks for watching if you watched, or if you watch, and keep loving and keep learning. Bye.